We present a novel and efficient approach for sketch-based modeling which uses a template model and deforms the template model according to the input sketch contours. In the past, the area of template-based modeling from an input sketch has not been visited well by researchers, due to which existing techniques have major limitations, mostly related to the time it takes for the overall process to last, and thus cannot be used in fast-paced production environments. We require the user to provide an input sketch as an image. Alternatively, the user can draw a sketch on a 2D plane using our prototypical interface using a mouse. We also require the user to trace the occluding contours on the image, since we will need occluding contours in a later step when we will find correspondences. We then retrieve a template model from our dataset that most closely matches the input sketch. To retrieve a template model, we extract 2D sketched renders from all the models from our dataset using powerful non-photorealistic algorithms. Since the sketch can be drawn from any view direction, we take 2D sketched renders of the 3D models in our dataset from many angles around the model. We convert the input sketch and 2D sketched renders into a shape descriptor feature vector, which we compute using Gabor filters. The result of this step provides the user with a template model, which is most closely matching the input sketch. After the template model is retrieved, we compute occluding contours of the template model using n.v equation. However, the extracted vertices do not lead to expected occluding contours, which cannot be used to find correspondences. To acquire correct occluding contours, we require the user to draw a B-spline curve on the 3D model surface as close as possible to the occluding contours extracted in the previous step. We then require the user to select very few anchor points on the B-spline curves and their corresponding points on the input sketch occluding contours. Our algorithm automatically subdivides the two curves and makes the two curves to contain equal number of points. Based on this information, our system then automatically computes template vertices which are nearest to the points on the B-spline curve points using KD tree algorithm. These vertices form the correct occluding contours of the template model. This treatment also naturally finds accurate correspondences between the occluding contour vertices and the occluding contour points on the input 2D sketch. This treatment makes our system much faster than Crevoy's method, where they have used hidden Markov model to find correspondences that incurs a delay of 2 to 10 seconds. Our algorithm finds correspondences in less than a second. Our next goal is to deform the template model so that its occluding contours fit those of the input sketch. We have used a combination of skeleton-based deformation and mesh deformation to achieve this goal. Skeleton-based deformation overcomes the large displacements between corresponding occluding contours. For small-scale displacements, we use mean value coordinates to compute the final deformations. Alternatively, we have also used Laplacian mesh editing, which preserves the internal geometry but is slightly slower as compared to mean value coordinates. Finally, we show some results of our proposed approach.